People often run into problems requesting spontaneous support from remote peers. In addition to verbal assistance, augmented reality enables visual assistance. However, current approaches rely on 3D reconstructions, which are often difficult to generate or cannot be used because of a poor quality. We present a system for capturing and annotating mixed reality light fields for remote assistance, based on a high-quality representation. A remote assistance session starts by asking the local user to capture a coarse overview of the environment. While capturing the images, our system records the tracked position and orientation of the user's camera and visualizes them on the remote user's device. The remote user may place annotations to guide the local user to a certain spot. After the remote user identifies the structure to be annotated, the local user is guided to capture a local light field. To restrict the amount of data that must be transmitted over the network, we capture only a small section of the spherical light field. The local user first captures 4 images of the object of interest from 4 corner points. The system derives the center and the bounds of the local light field. It visualizes the light field coverage as a tessellated sphere. The resolution of the tessellation corresponds to the desired sampling density. The remote user explores the scene using a mobile device with a touchscreen, for example a tablet or smartphone. The remote user may navigate by orbiting around the center of the spherical light field and zooming towards it. The remote user navigates the virtual camera to a suitable viewpoint for drawing the annotations. Upon a single tap on the object of interest, the system automatically determines the corresponding depth of the selected area, where it places the support plane as a canvas for the remote user's freehand drawing. The drawing plane is initially oriented parallel to the camera's image plane, but can be adjusted subsequently, if necessary. Once the remote user finishes an annotation, it is sent to the local user. Since both users share the local user's world coordinate system, the 3D annotations created by the remote user can be presented directly in the local user's augmented reality display. All annotations as well as the corresponding light field are stored online for later reference.